The X-Shooting ULLYSES project, an extension of the Hubble Space Telescope's ULLYSES program, aims to enhance our understanding of massive stars at low metallicity by combining UV and optical spectroscopy. This endeavor is crucial for interpreting James Webb Space Telescope data of the earliest stellar generations. The project focuses on the metallicity-dependent mass loss in massive stars, which significantly influences their winds and sets the boundary between black hole formation and pair instability supernovae. The UV region of the spectrum provides access to a unique suite of stellar wind diagnostics, including P-signal lines associated with abundant chemical species like CIV. However, the UV part of the spectrum presents challenges due to uncertainties in the ionization state, limiting the ability to quantify the mass loss rate in massive stars. Optical spectroscopy emerges as a critical complement to UV spectra in order to acquire accurate stellar and wind parameters. The HSTULLYSES project comprises two distinct parts: a 500-orbit program focused on young T-Tauri stars, and a comparable allocation of HST orbits for the massive star component. This project received substantial support from the massive star community, including backing from entities like the IAU Commission G2 on massive stars. It encompasses the entire range of spectral types and luminosity classes among OB-type stars within the Large Magellanic Cloud (LMC) and Small Magellanic Cloud (SMC) regions, covering all stars with masses exceeding 10 m. The dataset generated by this project will leave a lasting legacy, not only enhancing our understanding of stellar winds but also serving as a crucial spectral library from which to construct accurate population synthesis models. The X-Shoot U project also includes a small number of stars in even lower redshift galaxies. This combined dataset will significantly advance our understanding of massive stars at low metallicity, which is paramount for confidently interpreting James Webb Space Telescope data of the earliest stellar generations, making X-Shoot U a unique resource for comprehending individual spectra of low metallicity stars. The X-Shooting ULLYSES project, a community-focused endeavor, aims to provide high-quality, flux-calibrated, and rectified spectra for a comprehensive study of massive stars at low metallicities. The project's data products include reduced data, which have undergone various processing steps such as correction for slit losses, absolute flux calibration, and rectification to the continuum. These data products will be made accessible to the scientific community via the ESO Science Archive facility. The primary spectroscopic analysis tools employed in this project are Nanta codes that include a stellar outflow in spherical geometry, such as CMFGEN, fastwind, and power for stars with strong winds, and the plane parallel Nanta code Telusti for stars lacking strong winds. Research has demonstrated that the characteristics of structured winds significantly influence empirical calculations of mass loss rates, thereby shaping our comprehension of stellar evolution. However, the extent to which mass loss is influenced by wind clumping remains an open question. Within X-Shoot U, the impact of clumping on spectral and luminosity classes at various metallicities is investigated, leveraging advanced model atmosphere codes capable of addressing clumping properties with varying degrees of complexity. An early study into interior mixing was performed by Martins et al., submitted to A&A, using the CMFGEN code. This study revealed that nitrogen N enhancement occurs earlier in the main sequence evolution in the SMC than at higher metallicity. These early results appeared to support rotational mixing, which is theoretically expected to be more efficient at lower metallicity. Regarding wind properties, Figure 5 shows the mass loss rate of LMC and SMC supergiants studied by, respectively, Brands et al. In preparation, and Bax et al. In preparation, using a genetic algorithm method and the fastwind code. The results indicate that the mass loss versus luminosity relation becomes steeper in lower metallicity environments than at higher metallicity. These early results are based on the analysis of relatively modest subsets of the X-Shoot U data. More definitive answers will be obtained over the next few years as analyses of the full sample are completed. The X-Shooting ULLYSES project aims to provide a comprehensive dataset of massive OB stars in low metallicity environments, focusing on the Large Magellanic Cloud (LMC) and Small Magellanic Cloud, SMC. This dataset will be publicly accessible and complement existing empirical libraries, particularly the X-Shooter Spectral Library, XSL. The X-Shoot-U project will significantly enhance semi-empirical population synthesis models by incorporating state-of-the-art Nanta physics and rigorously assessing various spectral synthesis codes and analytical methods. The project's primary objective is to establish a high-quality, consistent optical database that complements Hubble Space Telescope, HST, ULLYSES. The resulting legacy datasets are crucial for accurately interpreting unresolved observations obtained with the James Webb Space Telescope, JWST. The X-Shoot-U dataset will offer a wealth of data, models, and new insights into massive stars in low-metallicity environments. It is anticipated that this project will lead to improvements in semi-empirical models, contributing to the refinement of fully theoretical population synthesis models. In terms of spectral resolving power, only the XSL and Lida archive complement the X-Shoot-U dataset. X-Shoot-U represents the most comprehensive, highest signal-to-noise ratio, and highest resolution library of massive stars, encompassing the broadest spectral range. The project will also provide an upgrade to the current Starburst 99 library, significantly enhancing the realism of population synthesis predictions.